fluid power formulas, how to calculate cylinder horsepower. So basically the formula for the horsepower on the cylinder is cylinder speed times force divided by 33,000. So if we're going to be working on the extension side of the cylinder, we calculated earlier the speed of the cylinder on the extension, and that gave us a number of 3.3333. We multiplied that by the force on the extension side of the cylinder, and that is pressure times area, and we were working with 1000 psi. It gives us a result of 12,566.4. So we say 12,566.4, and we divide it by 33,000 equals 1.2693 horsepower that is going to be required on the cylinder to extend at the speed that we need using the 1000 psi. Now that is on the extension side of the cylinder. What if we want to calculate the retraction side of the cylinder? How much horsepower are we going to need? And we say cylinder HP horsepower equals to the cylinder speed on the retraction side of the cylinder. We did that earlier, and we came out with 4.4445. So we say 4.4445 times the force on the retraction side of the cylinder, and we calculated it at 1000 psi with the area on the retraction side of the cylinder, and that came out to be 9,424.8. So 9,424.8 divided by 33,000 equals 1.2693. So now if we look at it, the same horsepower is calculated on the extension side as it is on the retraction side of the cylinder. The reason why we came out to be on the same horsepower is because we are using, on the calculation, we are using the same pressure. We are using the same pressure, and we are using the same GPM to move the cylinder at the same pressure. So when you have the same pressure and the pump moving the cylinder with the same GPM, even though you have a smaller area, you have a faster speed on the retract at the same PSI. And on the retraction, on the extension side of the cylinder, you have the same PSI, but you're moving a bigger area with a slower speed of the cylinder. So it came out to be the same horsepower that you're going to be using. Now in the real world, however, these forces are not going to be this uniform as we done over here at 1000 psi. In the real world, the extension of the cylinder may be 1000, maybe 2000 psi, and on the retraction side it may be 500, 700 psi, or depend on the application. It is very much possible that maybe a cylinder may require more pressure on the retraction side of the cylinder for some reason, you know. But in the real world, you usually are not going to come up with the same horsepower on the retraction or extension side of the cylinder. But for calculation purposes, we are using the same pressure and the same GPM to extend and retract the cylinder, and therefore it gives us the same horsepower. In the real world, the forces are not going to be that uniform, and you are going to have a different number. Also, another thing is, in the system, you might very well have the capacity to generate so many horsepower, you know. It is possible that the valve is set at 1000 psi, that the cylinder can can take as many 1000 psi on the retraction side, but it may not need to take 1000 psi, so it may only need maybe 200 psi or very minimum pressure, and you're not gonna need that many horsepower on the retraction side of the cylinder. However, the system and the cylinder is capable of producing that many horsepower that may at one point be required in the system. So that's it for now. This is how you calculate cylinder horsepower. I'll talk to you later. Bye bye.